Hello, welcome to my channel. Today let's look at the daily challenge question. 782, transform to chessboard. You are given an n by n binary grid board. In each move, you can swap any two rows with each other or any two columns with each other. Return the minimum number of moves to transform the board into a chessboard board. If the task is impossible, return -1. So let me show you two examples of a chessboard value chessboard. So one is when n is 4. You can see that there actually each column there are only two patterns in column or row. And also you can see that if the first element of a column is different from the first element of first column, then all the elements in that column will be different with the corresponding element in the first column. So the same is for the row. So this is the third column is the same as the first column. So then actually all the elements are the same. So it will be either different or either same. So actually through this we can actually put it into the code. So the first 0, 0, 0, right? 0, 0 exclusive all board 0 J. In Java, we may need to have another parenthesis. So because the X exclusive or the priority. So yeah, so this one, if it's not identical, then actually it's not a valid it's not a valid chessboard. So we can return -1. So the exclusive OR operator. So this operator only returns one two element is so one two binary element is different. It will return 1. So like we can also, if one exclusive 0 is 1, 0 exclusive 1 is and 0 exclusive 0 is 0. So this one also hold for the row. So it's similar. We can write it later in the code. So the second property of a value chessboard is if you add all the elements in the, or you count all the ones in one column, and also you count the number of zeros in the one column, they actually are they are almost identical. So in when n is even, they are identical. But when n is odd, here we have 2 ones and 1 0 in the first column. So so it can maximum difference can only be 1. So we can actually so the count of ones and count of zeros in each column or each row can only differ by 1 or 0. So this is another property. So if it doesn't hold, then we need to return -1 again. So so this part is to decide if we can convert to a value chessboard. From now we need to decide the number of operations or like swaps to make the board a chessboard. So the number of swaps we actually can there is still 2 possibilities. One is n is even. When n is even, there is only we can actually check. Just look at the first row and the first column. So there is for the row, there is only two patterns. Okay, actually let's yeah, there is only 2 patterns. So it will be either 0 1 0 1 or 1 0 1 0. So we just need to calculate the difference between current row and this and these 2 patterns. And select the pattern with a smaller difference. Yep. So, but when n is odd, actually it's already, we don't have a choice. There can only be one pattern for the, because for example this first row, one for the n for this 3 by 3 3 by 3 board. So we can only have a 1 0 1. So we just need to we need to calculate the difference. And the pattern. So and then we then we do the same for column, and we need to divide by 2 to get the swaps. So okay, so now we went through the process. The details will be in the implementations. So also the time complexity is O(n), where n is the elements in the board. Time and okay, so now we can start to doing the implementation. So firstly, we getting the length of the getting n, and then we can do the first check, which is number 1 here. So what we do is we go through all the columns and all the rows. And we can copy the code, and also and also we need to do the same for the row. So actually we can just modify. So this means we check if the first element in this row is the same as the first element in the first row, then the jth element in this row will be also need to be the same as jth element of the first row. So, but if they're different, both need to be different. So so here we can. Then we need to do the second part, which is to count the ones and also count the zeros. So the count of ones, actually what you can do is you can sum all the ones in one column and one row. Then that's actually the count of ones too. So we can do a row sum and also do a column sum. Let's so this one is a column sum, and So if the so the number of zeros will be minus n minus column sum. So if this difference is larger than 1, then we need to return -1. Similarly, we need to do the row sum part. So row sum is we can just do the first row, and then row sum. We add the row sum, and also this part is the same. So yeah. So now we have done both steps to check if it's valid. So if we didn't return -1, then which means it is valid. So we can now calculate the number of swaps. So we can initialize the answer is 0. Then we need to have two possibility. Two conditions. One is n is odd. As I said, there can only be one pattern. So we can then if else will be n is even. So when n is even, which is actually it's more straightforward when it's even. We can actually firstly do the even condition. So we need to I think we need to have another sum here called we're gonna call it a column XOR sum. So this sum will be we can get we can add this I divided by 2 and I mod 2, and then XOR this then XOR the board value. So what does it mean is so for example this first, so the column the row column 0 will be it will be 0, the mod will be 0, and the column 1 the mod will be 1, and then it will be 0 again. So what it does is it evaluate the XOR of this this element with this value. So then for this pattern, because all of them are different, so it means it will be 1 and 1 and 1. So it add together will be n. So but if it's different, for example, if it's a 1 1 0 0, now we actually have all the columns. We have 2 columns in the wrong position, right? So this one and this one XOR then sum together will be 2. So this XOR column XOR sum will actually getting the difference between the patterns and the current border. So let's similarly here I need to have a row XOR sum, and yeah. So now actually when it's even, the answer will be row XOR sum and n minus row XOR sum plus column XOR sum n minus column XOR sum, then add these 2 together and divided by 2. So actually the answer will be this part, this calculation, and when n is odd, so when n is odd, we actually can use the call sum or row sum to decide the pattern. Then we just need to check if the difference, the difference between the current row or column with the valid pattern. So if call sum is larger than n minus call sum, then which means we have more ones than zeros, or we can call it the pattern will be 1 0 1. So it will need to start with 1 and then the even even position will be 0. So on the other hand, if it's then we will have 0, 1, 0. So when it's in the 1, 0, 1 pattern, the XOR of 1 and 1, 1 and 0. Oh, so then it means the core XOR sum is the valid number. So we just need to minus n minus core XOR sum. Answer. Then we need to divide it by 2. So similarly here, if it's 0, 1, 0, then the XOR this one will be 0. So so then the core XOR sum is so we just need to add this. Similarly, row sum is symmetric. So actually, we just need to change it to row sum. Yeah. Okay. So I think now it should work. Let's check. Maybe there is still some errors. Should be J here. And what else? Okay. So it seems correct. Let me submit it. And okay, so it works. And okay, so yeah, actually, let's summarize So firstly, we needed to decide if it's a valid pattern. So we follow 2 invariants. One is the it will be either in one pattern or the other, but you cannot have more than 2 patterns in column or rows. And also, this 2 pattern is completely opposite with each other. The second is a count. So the count of ones and the count of zeros in each column or row can only differ by 1 or 0. Then we calculate the number of swaps under 2 different conditions. One is n is even, and the second is n is odd. So the n is odd is a little it will be fixed pattern. I mean, for this existing board, but for the existing row or column. But for the n is even, there will be selection, either go 0, 1, 0, 1 or 1, 0, 1, 0. That's why in the n, when n is even, we actually need to do a math.min. But in the when n is odd, we actually don't need to find a mean. So yeah, I know this question is a little tricky, and but you might need just to think about it, and so hopefully you can understand now what I just try to describe. And also I will put the code in the GitHub. And so if you have any questions, you can comment in the bottom of the video. If you like it, please subscribe or click like button. And So so I will try to do the daily challenge every day and upload videos. So thank you for watching and see you next time.